Assalamualaikum warahmatullahi wabarakatuh to Dr. Hassan. Today our group want to present about our project structural analysis from section 10 for group 4. First of all, I want to introduce all of our group members. First, we have Muhammad Firdaus bin Muhammad Fazli, then followed by Najwa Wahida binti Hussein, and me myself, Azwar Rehana binti Azim Razaimin. The fourth member is Patricia Lija, and the last member is Hamim Daniel bin Hartika. Assalamualaikum warahmatullahi wabarakatuh to Dr. Hassan. My name is Azwar Rehana binti Azim Razaimin. My number matric is CF200120. Today I will talk about my introduction for this project. Do you know what is meant by bridge? Bridge is where a structure that is built with a span that can withstand physical obstacles without interrupting or intersect with the way that underneath it. The part that sit underneath is such as river, road and also valley. During the ancient time, the bridge design is a lot simple, with the material used also easy to find, such as timber. After the millennium, the civil engineers have variety of resources that they can use to build and design the bridge. There are several types of bridge, which is arch bridge, truss bridge, tight arch bridge, cantilever bridge, suspension bridge, beam bridge, and also cable stayed bridge. For this project, we decided to use truss bridge in designing our group bridge. This truss bridge is statically determinate, where the determinacy is based on the number of joint, the number of member, and also the number of reaction. The reaction for this truss is that we use pin support and also roller support at each end span. The size of this bridge is according to the maximum weight and height of a truck. This is also referring to the H2 specifications to avoid any failure happen to the bridge design. This design also consider all the dead load and live load. So that's all from me in introduction. Thank you.
Hello, my name is Patricia Lijas, matric number CF200189. Today I would like to present part 1, which is the layout design for our bridge truss design project. As you can see here, this is the front view of our bridge truss. This is the plan view, and lastly, this is the planar view. This bridge truss design is inspired by Pennsylvania bridge truss. Our bridge truss design is the simplified version of Pennsylvania bridge truss. Okay, next is the bridge dimension. Here is our bridge layout design with dimension. From the layout, we can see that the bridge height is 3 meter and the length span is 18 meter, with 3 joints of 3 meter apart from each other at the middle section. The determinacy of the bridge truss is depending on us, so we choose to design a statically determinate bridge truss. That's all from me.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Firdaus bin Muhammad Fazli. My matric number CF20015. And for my part, I will present for part 2, which is the analysis for our project. And for this part, I will explain about the internal forces. And before we start to calculate the internal force for our bridge, we should know whether our bridge is statically determinate or statically indeterminate. How to know our bridge is statically determinate or statically indeterminate is, first one, find out the reaction for our bridge, which is our bridge is reaction 3, member of our bridge is 21 and the joint is 12. After put in the formula, we found out that m plus r equal to 24 and 2j also equal to 24, which is 24 equal to 24. If the m plus r equal to 2j, that means that our bridge is aesthetically determinate. After we found out that our bridge is statically determinate, what we should do for the next step is to to calculate the direction for two support for VG and VA. And actual load for our bridge is 300 kilonewton. After do the calculation, we found out that the amount of VG is 150 kilonewton, and for VA also 150 kilonewton. For horizontal load, we don't have a load because we don't assume any load from the horizontal load. That means that no load or no reaction force for horizontal load. The next step, after we calculate the reaction force, and the next is we can proceed to calculate the internal force. There are three methods that we can use to calculate the internal force. The first one is section method, and second one is joint method, and the third one is alternative method. And for this project, our group decided to use the joint method to calculate the internal force. As what we can see here, I put one example how to use the joint method. The first one, we pick the one joint and then we calculate the member which is connected with the joint. And here the member has been connected with joint A is a member FAH and member FAB. Then we can get the internal force for FAH and FAB. It's some method to calculate for all members using this joint method. Next, after we finish calculate all members, then here the answer for the internal force for manual calculation using joint method. So what we can see here, all members have their own value, and certain members have a zero internal force. And for the last, what we should do is to make a comparison between a manual calculation and a software calculation. So what we can see here, the range of differences between the manual calculation and software calculation is from 1% to 8%, which is below than 10%. That means that our manual calculations is still acceptable because it's not more than 10% differences from the software calculations.
Hi, Assalamualaikum and very good morning to Dr. Hassan. My name is Najah Wahida binti Hussein, CF 200-205. Today I will continue with part 2 for result analysis for the calculation for this project. So this is our bridge for 18 meter long, and next I will explain to you what we have done for our calculation. First, we are doing our reaction force for actual load to find the VG, which is our VG is 0.50 kilonewton, and we have to find VA, which is our VA is 0.50 kilonewton, and our HA is 0. That is for our reaction force. We have to find that. And next, we have to find the deflection of the truss bridge, which is we have used joint method. First, we have to find every joint that have in a bridge, which is joint A, joint B, and many more. And we have to find a force, force that have at AH, AB, and that is for joint A. But if you want to find joint B, you have to find FAB, BH, like that. Next, so this is our deflection of the truss bridge for all member using manual calculation. After all calculation that we calculate with manual calculation, this is what we get from the calculation. And this slide is for comparison manual calculation between software calculation. So after we calculate use manual calculation, we also compare the result with software calculation. So this is our result that we can find, and range of difference between manual calculation and software calculation, they have 1% to 8% only. That's all from me, Najwa Wahida, for our part 2 calculation. Hope you can understand what I want to explain. Thank you.
Assalamualaikum. My name is Hamim Daniel bin Hartika, CF 200105. Today I want to talk and discuss about my part, which is discussion, conclusion, and summary. Okay, for the discussion, for our group, we want to determine whether the truss is determined or indeterminate using the stability and determinacy equation. Number 2, the method to calculate for the internal force is method of joint. The joint method is the easiest way to determine the unknown force that acting in a specific truss member. For the first step, we are going to find the reaction at the support first. Other than that, while doing the calculation for each member, we need to identify whether it will be a tensile or comprehensive force. This is because any positive force will be tensile force and any negative force will be compressive force. After that, we compare the calculation that been made in manual and in software. By comparing these two calculations, we find some differences in both data in terms of value that we have used in the form of decimal places. There are differences, but not too far. For the summary, this truss bridge has a height of 3 meter and a length of span 18 meter, with each joints of 3 meter apart from each other. The truss bridge and the analysis of it were calculated by using the manual calculation. In order to make sure the calculation that obtained was correct, by analyze, the truss bridge once again was calculated by using computer software, which is Lean Pro. The software is programmed to analyze the bridge no matter how kind of bridge is it. The calculation of the software carried out easily and quickly. With that, the analysis of the bridge can be ensuring to be safe, and the manual calculation can be checked to see if it is correct or not, besides save a lot of time. Okay, for the conclusion, we can gain new experience in design our own bridge layout. Other than that, we can practice theory that have been studied in the cases. Besides that, we can learn that the design of a bridge plays a big role towards the strength and the stabilization of the bridge. And last but not least, we have to make sure the design layout of the bridge is suitable, safe, and economic, and have its own aesthetic value so it will look more exclusive with high safety. So basically, that's all from me. Thank you for listening and have a nice day.